Hello again, old friend. Glad to see you are still with me and breathing. If you remember from last time, we made a command that adds two integers together. Today, we are going to add the ability to add more than two integers together, as well as check for any non-integer arguments. Real quick, let's cover something I skipped over. There are two types of data types. The data types you are familiar with are known as reference types, as they refer to objects. These data types are also referred to as non-primitive types. On the other hand, primitive data types are the most basic form of storing information. Your computer stores all information as a sequence of ones and zeros. This sequence of integers is known as binary code. A single integer is referred to as a bit. When something is referred to as being 64-bit, this means the object has 64 bits to store information. A boolean is a true or false value that is only 1 bit long. However, your CPU cannot address anything smaller than a byte, so the first 7 bits are unused. A byte is an 8-bit integer, which is any integer between -128 and +127. A short is a 16-bit integer between -32,768 and +32,767. An int is a 32-bit integer between -2,147,483,648 and +2,147,483,647. A long is a 64-bit integer, which is any integer between -9 quintillion, 223 quadrillion, 372 trillion, 36,854,755,807 and +9 quintillion, 223 quadrillion, 372 trillion, 36,854,755,806. That's huge. All of these values can be used to store integers. The first bit in any primitive used to store integers denotes the sign. 0 is included as a positive integer, so the max positive integer is one integer closer to 0 than the max negative integer. I just answered a whole bunch of questions you didn't even ask. The main thing you need to remember is there are different data types which store different sized chunks of information. But why do we need so many different ways to store integers? Why can't we just use a long every single time and call it good enough? Let's store the number 1 as a byte and also an integer and compare the two. As you can see, the number 1 only requires 1 bit. The byte has 7 unused bits, while the integer has 31 unused bits. That's over 4 times as much information that is being stored. Information that has no purpose. By using the simplest data type available, you are reducing the amount of memory being used. Let's finish up with the primitive data types. We already covered all the ways of storing integers as well as booleans. Let's talk about floating point numbers. Floating point numbers are numbers that have a decimal. A float is a 32-bit floating point number, and a double is a 64-bit floating point number. We aren't going to get more detailed than that, as it gets rather complicated. The 8th and final primitive data type is a char. A char is a single 16-bit character. A char can store any ASCII values. If you're interested in knowing, ASCII code is used to represent characters as numbers. This makes it easier for computers to translate binary code into letters and symbols. Now what about those reference types we were using? Why would we want to use those types that take up an increased amount of memory over the primitive types? The main reason is reference types are a great tool of storing a collection of methods and information. For example, we have been using the integer class instead of the int primitive. If we take a look at the integer class, it contains a ton of useful methods. You are already familiar with the parseInt method. The integer class gives that method a place to be stored in an organized manner, so that you, the developer, can easily find and use it. Now let's open up our add command class and change any variables with a data type of integer to int. Now that our program is operating more efficiently, let's talk through our problem. We want to add an unknown amount of arguments together. The number of arguments is unknown because the end user can input any number of arguments. We also want to check if all the arguments are integers. This is an excellent example of a scenario when you would want to use a loop because we want to execute our code a non-predetermined number of times. The type of loop we are working with today is the for loop, not to be confused with the for each loop. To use a for loop, you need to know 3 things. where you want to start the loop, where you want the loop to stop, and how much you want it to increment. Each one of those makes up a part of the for loop structure. Your average for loop looks like this. 3 parts with a body. This first part is your starting condition. This is run before the loop is executed. I will define a variable named I that is equal to 0. The second part is the condition. If this is false, the loop will stop. I'm going to check if I is less than 5. So this loop is going to stop once I equals 5. The third part is where your increment goes. You could write out I equals I plus 1, but the shorthand for this is I plus plus, which increments the variable up by 1. And this part is run after the loop completes an iteration before the next one begins. We now have a complete for loop. I'm going to log the value of I each time the loop is run. You can see every time the loop runs, starting at 0 and ending with 4 with a total of 5 iterations. Now let's make a for loop that will loop over the list of arguments. We are going to change our if statement to check if the number of arguments is more than 1. Then we are going to define our for loop. Since the index of the first element in an array is 0, I'm going to make my starting position 0. We only want the loop to continue if the current index, or I, is less than the total number of arguments. Otherwise, we will get an array index out of bounds exception. On each iteration, we are going to increment the current index, or I, by 1. And the shorthand for this is I++. We now have a functioning for loop. Let's add our code to the body. When the for loop is run, the body will execute. On the next iteration, the body will execute with the new value of I. Since I represents the index, we can use this to get our element from the list using bracket notation and set it to a variable. Now we need a way of adding this number together with the next number in the list. This is where we run into a problem. I could create a variable named total and add the current number to this, but on the next iteration, the total would be reset. So I need to define the total outside of the loop. Now inside of the loop, I can add the current number to the total. The shorthand assignment operator for adding to a variable is plus equals. So now after each iteration, the total will increment. So let's send the total to the player in a message after the loop executes. We can now delete this extra code. First problem solved. You can now input more than 2 arguments. However, we still need to check for errors. The error we want to check for specifically is the number format exception, which is thrown when we parse an integer from a string that is not an integer. When your program throws an exception, it is letting you know it ran into an error and it will print a stack trace. So if this string said hello or H3110, it would throw an exception. To check for thrown exceptions, we use a try-catch statement. This is a try-catch statement. The block labeled try contains the code you expect to cause the error. The block labeled catch executes when an error occurs. You can be extremely vague and catch any error or only catch specific ones. It's best practice to put the minimum code in the try block and only catch the error you need. The code you put in the try block executes the exact same way inside the block as it does outside. So let's use a try-catch statement to catch the number format exception that is thrown when we parse a string that is not an integer. This is where we run into a problem. Our compiler is telling us current number isn't a defined variable when we can clearly see it is indeed defined. We have an issue with the scope of our project. Scope can be hard to understand, but I will try my best to explain it in detail. I created this example class to help you understand scope. At the top of the class, under the definition, is where the variables defined in the global scope or class scope go. These variables can be accessed by any of the functions in this class, but not by any other classes. As you can see here in the global scope, I have defined the credentials of a person. In this person class, I have 2 functions, on death and change marital status. Either of these functions can use variables defined in the global scope. Let's say I was working in the change marital status function and I wanted to access the value of was natural from the onDeath function. I cannot access this value as the variable is not in the scope of this function and I get a reference error. We can create a variable that is local to this method with the same name and it will have no effect on the other function. The same thing will happen if I try to access the was natural variable from the class scope. Now let's look at the onDeath function. I can access the was natural variable because it is passed into the onDeath function. Each time you enter the body of a class, function, or loop, you are creating a new level of scope. Think of scope like a flowing river that splits off into various streams. Each stream gets the water from the streams above it, but cannot access the water from the lower down or equal level streams. Hopefully you have some understanding of what scope is. Don't worry if it is still unclear. As you gain experience, it will become natural. We need to widen the scope of current number by moving it up a level. Our try-catch statement has a block. Since our variable is nested within the try block, it is not in the scope of our for loop. So we need to widen the scope of current number by moving it up a level. I'm going to make current number local to our for loop by moving it outside of the try block. This is how you declare a variable without assigning it. The default integer is 0, but most other data types will default to null. We are assigning our current number on the next line, so this is going to be overridden. We now have a syntax error. Current number is not assigned within the scope of the catch block. We assign a number inside of our try block, but because the try and catch blocks are both at equal levels, they cannot access the variables from within each other. So we need to stop the loop to prevent the compiler from reaching that line after running the catch block. To break out of a loop, use the word break followed by a semicolon. I don't remember if I talked about it or not, but a semicolon marks the end of a statement. You can split one statement into multiple lines or put multiple statements onto one line. But if we break here, the message will still send, so we want to return. I'm starting to get to that point where I can't remember what I've already taught and what I haven't, so sorry if I sound like your 80-year-old professor the school made retire. Anyways, a return statement marks the end of a method. The computer will stop executing code at that point, which is why we return at the end of the onCommand method, because it requires a boolean. If the method were void, you'd not have to return a value or even return at all. So let's return true here. If you want to see what returning false does, feel free to test it out. Above this line, I'm going to send a message to the player letting them know they have input an invalid argument. I can even include a detailed message as to which argument was invalid. And just like that, you are an absolute legend. Let's test out our command as well as try and break it. One more thing before you go, I have something important for you. Homework. If you want to prove your skills with a Z, make this command work with floating point numbers. I will post the answers in a pinned comment in 1 week. Send your answers in Discord. If you have any questions about what I talked about, feel free to leave a comment or join my Discord and I will try my best to get back to you. That's all for today and I will see you next time. Goodbye.